Hi everybody, my name is Heather Thorstensen. I'm the Manager of Communications for Sigma Xi, the Scientific Research Society. Welcome to our Google Hangout today. We're going to be talking with Dennis Meredith about using visuals to communicate science. I have a couple of intro slides that I'm going to share to get going. So if you guys aren't familiar with Sigma Xi, we are the Scientific Research Society. We're an honor society for scientists and engineers. One of the things that you can do with the information that we're going to be covering today, if you're a student in high school, if you're an undergraduate college student, or if you're a graduate student, is to participate in Sigma Xi's Student Research Showcase. The deadline to register and submit presentations for this showcase is March 16th, and the showcase is March 23rd through the 29th. You can learn more about it at sigmaxi.org/student-research-showcase. If you have any questions today during the Hangout, feel free to ask those. I've enabled the Q&A app so you can type in your questions on the right side of your screen and submit them. We'll be taking questions after our speaker Dennis makes his presentation. You can also give questions a +1 to get them to the top. So now I'm going to introduce our speaker. Hold on, I'm just trying to get back to the page that has his picture on it.
Please do.
I just have to get to it right here. Hold on just a second. Okay. So Dennis Meredith is a science communicator, and his work has included service at some of the country's leading research universities, including MIT, Caltech, Cornell, and Duke. He has worked with science journalists at all the nation's major newspapers, magazines, and radio and TV networks, and has written well over 1,000 news releases and magazine articles on science and engineering. He has served on the executive board of the National Association of Science Writers and is a contributor of its magazine Science Writers. He is an honorary member of Sigma Xi. So now I'm going to give it over to Dennis so that he can say hi and start his presentation.
Hi, Heather. Thanks very much. First of all, I want to assure you that I see that I'm wearing the same clothes that I did in the portrait. I do have other clothes. I just happen to put those on today. So I'll start by sharing my screen here so you can see. And is it sharing?
Yes.
Okay. As the advertising says, I'll be talking about using visuals to communicate science. Feel free to email me at dennis@glyphis.com if I can offer any help or any advice. And I'll be giving you a lot of tools for communicating your research visually. They're all available on explainingresearch.com, and I'll give you specific URLs, specific ways to manipulate the website to get them. So I'm going to start by convincing you that it's in your best interest to learn communication. And this is a good example. This is the results of the Job Outlook survey by the National Association of Colleges and Employers, and you'll notice that they list communication skills very high. Communication skills are invariably listed among the top skills that employers want in their communicators. So it is very much worth your while to learn to communicate both written and verbally. And also visuals are a critical part of this communication, as I'll show you later. Now, this is the image that I suggest that presenters keep in mind when they're thinking about their audiences. Now, I'm not being pejorative here. My point is that your audiences are primates, and you are a primate. We all have perceptual and information processing machinery in our brains that you have to take into account when you're communicating with your audiences. For example, up to 40% of your cerebral cortex is devoted to processing images. So if you're using images effectively, you're engaging much more of the cerebral cortex of your audiences than if you don't. That also means that this is not a valid model for communication, although I think a lot of presenters have this in their heads either explicitly or implicitly. They think, well, okay, all I got to do is take the graph or the chart from my paper and put it up on the screen and talk about it, and the information will automatically pour into my audience's heads. But that's not the case, and I'm going to talk specifically about what you have to do to get into your audience's heads besides pouring knowledge into their heads. Now, another reality is that your audiences are all very visually sophisticated. They go see special effects movies like Avatar, they watch television news and television documentaries, all of which have very professional quality visuals. And so your visuals need to be professional quality as well. And I'm not suggesting that you need to spend millions of dollars on special effects like Avatar did. All the tools and the techniques that I'm going to give you are very easy to use and are either cheap or inexpensive. So you don't have to worry too much about spending a lot of time and many times not even not a lot of money to do good visuals. Another reality you face these days is you compete with the entire world, the entire online world, and this is unprecedented. Your audiences have smartphones, they have laptops, so rather than listening to you, they could just as easily be writing that email or writing that letter, that paper, or making restaurant reservations or texting. So you have much more of a challenge than previous generations of presenters to grab your audience's attention and engage them. And visuals are a great way to do that. Now, I advocate that scientists use what I call a visual vernacular, and that is anytime you're going to do a slide presentation, any kind of presentation, you think, how can I make this concept visual? And my favorite saying in terms of visual vernacular is say cow, see cow. Now, this sounds a little weird. This comes from television news. Television news people know that if they're talking about a cow, they need to show a cow on screen. So when you look at a television news segment about, say, the economy, you'll see video of money being printed. If you watch a segment about gasoline prices, you'll see gasoline being pumped. Now, this isn't specialized video that they've taken for the purpose. They usually just grab it right out of the library. But they know that no matter how many words you use to describe a cow, nothing beats a picture of an actual cow. Now, scientists have a unique opportunity to use visuals to explain their work, and I'll talk about some of those opportunities. If your work is distinctive, if it's different than other work in the field, visuals will help you make that distinction in a vivid and engaging way. If your work relates to some popular topic, if there's this terrible disease going around, you can show the sufferers of the disease. You can show its impacts and not just show graphs and charts to talk about the data. So images will help you connect your work with that popular topic. If your work has an historic angle, then you can show old video or animation or images to connect your work with that historical, put your work in that historical context. So it helps people relate to your work if they know how it's connected with the history that they know. If your work is high-tech, if you have a new technology, rather than just describing it or showing diagrams, you can show the machines, you can show them in action, you can show the results. So visuals really help you explain technology. This is a high-tech cow, by the way. This is the 22nd century cow. Finally, if your work is interdisciplinary, if you're a biologist talking to physicists or a physicist talking to biologists, you can reach across that disciplinary boundary by using visuals to engage them. Now, I did not say cow, see cows. Now, one of the prime sins, the cardinal sins that scientists commit is to put too much data on the screen. If you're just talking about brown cows, just show brown cows. And this is a good example. I took this off the web. This is a chart that somebody used in a presentation. And this represents that cardinal sin of just putting too much data on the screen. Now, you know this person wasn't going to talk about every bit of data on this screen. So if you're going to talk about row 3, just put row 3 on the screen. Redo the chart just to show what you're going to be talking about. Now, this also represents another cardinal sin that scientists communicate, and I've seen it over and over again. They put text on the screen that's not meant to be read or can't be read. For example, this person left the caption on this chart, and all the other text in the chart isn't readable. Only the headline is readable, or the label at the top. So the general rule is text has to be at least 24 points to be visible in most venues. 24 points or larger. Now, another thing is that people remember more of what they hear and see than what they hear or see, as you can see from this chart, and this bar graph. Now, this bar graph also represents very poor visual vernacular. For one thing, it has too much non-data ink. That's a saying by Edward Tufte, who's a master at communicating visually. By non-data ink, it has too much stuff in there that has nothing to do with the data. It's got three-dimensionality. You don't need that. You don't need sort of the random colors of the bars. You certainly don't need that background with the fish in it. There are also other things wrong with this graph. It's got a vertical label on the y-axis. People can't read sideways. They tend to lose that. It's ineffective. It also has the reference at the top of the screen. The reference needs to go at the bottom. It also has a label, and I'll talk about that later, why you don't want labels. Retention of information is a label, not a headline. So compare this graph, this bar graph, with this one. So you can see very clearly what I want you to look at: 10%, 35%, 65%. People remember more of what they hear and see than what they hear or see. So what that means is, the reason is that different parts of your brain process spoken and written language than the part that processes images. So that if you're using visuals, you're engaging more of the cerebral cortex of your audience than if you don't use visuals effectively. Now, I always wondered why the 65% seemed to be was more than the addition of the 10% and the 35%. And the reason I found out in a paper that was published last year was that your visual cortex processes sounds as well. In other words, you think about evolution. If you're a cave person living in the jungle and you hear a roar, you want your visual cortex to immediately turn itself on to watch for something dangerous. So that means that using your auditory plus visual is going to really turn that brain on in your audiences. Now, I mentioned using headlines, not labels. A headline is something that tells the point of the slide. It grabs your audience, tells the point of the slide, and it's heard and seen. In other words, people look at the headline, they get the point of the slide, and then they can listen to you with an informed understanding of what you're talking about. Now, I'll give you some examples. This is a label. By the way, this is a sea cow. This is a label, Florida West Indian manatee. And this is a headline, manatee extinction without additional protection. It tells the point of the slide. And this also holds, by the way, for graphs and charts and other data. You want to put the headline to tell what the major point of your slide is. Here's a label, pancreatic cancer, liver metastasis. Here's a headline. So people listening to you discuss this tumor, this liver tumor, will know what your point is as you discuss it. Now, let's review a little bit. Effectively designed slides have an editorial headline. They've eliminated non-data ink. They've made only a few points. You can only make about 4 to 7 points per slide. I've heard graduate students tell me that their professors tell them put all the data on one slide. That's wrong. Don't do that. They've engaged the eye using color and image, and I'll talk about visuals in a minute. And your slides were designed to guide the eye. In other words, you want to design your slides so people know where they're supposed to look. Here's an example. This is that bar graph that I showed you earlier. And you're not sure from this layout, from this design, exactly where I want you to look. So what I did was I just add a little color, and your eye is drawn to the percentages and the and. So you know where I want you to look. Similarly, I use arrows sometimes to point out where I want people to look at the slide. So use color, design, layout, arrows, whatever you need to do so that your audience's eyes are automatically directed to the point in the slide where you want them to pay attention to. Now, I've heard a lot of scientists say, well, how about eye candy? Just pretty pictures. Are they useful? And here's a good example. This is a mathematical surface called a Keown's surface. And this artist, Luc Bernard, rendered it as this beautiful glass object. But a mathematician would say, well, that's just a pretty picture. This is the way we would normally convey the surface, a Keown's surface. And so the other is just eye candy. Well, here's another example of eye candy. These are other mathematical surfaces that Bernard rendered as these beautiful glass objects. This won the 2006 Visualization Challenge, and the earlier one I showed you won the 2010 Visualization Challenge. Now, I argue that eye candy is useful. Just pretty pictures are useful in that they engage the visual cortex. They engage that 40% of your cerebral cortex that processes images. So they open people to your points. They get them ready. They prepare them to listen to what you have to say about your research. So you can show data slides, certainly, but always think about showing some eye candy to get them interested. Now, this also holds for scientific audiences. Scientists aren't immune from being attracted by eye candy. This is a good example. This is an article on the sweet taste receptor by biochemist Charles Zucker. So Zucker said, well, I want to get the cover. I want to give them a little eye candy. So he commissioned this professional photographer to come in and shoot this pretty yummy, this nice yummy pastry. And the photographer actually photoshopped in the mice. They sent it to Cell. Cell says, yeah, that's just a pretty picture, but it belongs on the cover. So the editors of Cell and Zucker knew that eye candy is useful for attracting a professional audience because of course, they are primates as well. Now, a good place to use eye candy, just a really pretty picture, is your opening slide. This is a good example, to be honest, of the kind of slide that I used when I first started giving presentations. And then I realized I wanted to give my audience the sense that they were going to see a professional presentation in terms of visuals. So I commissioned this piece of art that sort of exemplifies the research of the communication work that I do. So you should go find a nice image or make a nice image, and I'll show you how to do that later, that really tells your research, tells the story of your research visually, and use that as an opening slide, as sort of your trademark slide. Now, here's some examples of really beautiful images that are out there. These are cells in the eye. These are microtubules in the cell with mitochondria, the blue purple part. This is a snail and a whelk attacking one another, I think. You wouldn't guess, but this is a tomato seed. It also holds for illustrations. This is HIV. These are carbon nanotubes. These are chromosomes segregating during cell division. And here's a phage T4 virus infecting a bacterium. So there's just whole bunches of beautiful images out there that you can use. Here's where you can take a look at some of these. You go to explainingresearch.com, Best in Show, click on Best Images, and there's a series of galleries of award-winning scientific imagery. So you can kind of get a sense of what people are doing out there to really illustrate their science in a very compelling visual way. Now, more broadly, there's a whole bunch of image sources out there. To find those, you go to Explaining Research, References and Resources, and click on Chapter 3, Give Compelling Talks. And the Chapter 3 listing has a long list of sources for free and commercial images, illustrations, animations, and videos. So you can go explore those to find images that really exemplify your work, that convey your work very compellingly in terms of visuals. Here's some examples. I'll start with some free sources. You've already paid for these images and paying your taxes. There's a link to a USA.gov webpage that has links to all the agency image galleries, and you can go explore those and see whether there are images there that the government has produced that tell the story of your work visually. More broadly, you can search Google. It has an advanced image search that lets you narrow down, look for images that are specifically about your work. There are a lot of private sources that are free, like Welcome Images. They have a lot of medical and biomedical images, as well as historical images that are quite lovely and are free for you to use for your presentations. Wikimedia Commons has some 22 million, it's probably larger now, 22 million free images that you can download. There are also free stock shot houses like Morgfile, and there's several others listed on that that list of links that I gave you. Then there are paid stock shot houses. The most prominent is Getty Images. The stock shots that you pay for tend to be more professionally done. They tend to be nicer than the free ones. Now, this is a good example. This is a cross-section of an aquatic biosystem. Another widely used paid stock shot house, commercial house, is Shutterstock. Here's an example of a Shutterstock piece of artwork. If you're talking about viruses infecting the bloodstream, you might use this as a backdrop. There are also paid stock video houses. iStock and other places have a lot of stock video of various scenes, including this, in this case, sort of water droplets, abstract images of video of wet water droplets. Here's a Luna Blue. This is a good example of animations that you can download. You can pay for stock video animations. So you can imagine putting this in the background as you open a talk about DNA and how it would engage your audiences, even though it is eye candy. If you're looking for public domain video footage, there's a place called videouniversity.com that sells a guide for about 30 bucks to public domain footage. They don't have the footage on their site, but they tell you where you can get it, how to use it, how to download it, and how to put it into your presentations. There's also places like the Animation Factory that have a lot of these cartoon-like animated GIFs. They're called GIFs. You wouldn't use these for technical presentations, but they might be good for lay-level presentations. So you want to take a look at Animation Factory for these animated GIFs. Later, I'll talk about how you can make your own animated GIFs and how you can use them in presentation. Excuse me. Crystal Graphics is a place that has tons of backgrounds, templates, videos, and so forth that you can use in presentations. It's good to go explore these just to see what's out there. You may find something that's useful to you. Now, let's say you look through all these sources and you don't find any that really tell the story of your research visually. It's not difficult to think in terms of visual vernacular and create your own visuals. It's not hard at all. You just have to think visually. This is a good example. This is Felice Frankel created this lovely image of what's called a ferrofluid. It's a magnetic fluid. So she put a droplet of this ferrofluid on a slide, and she was thinking visually, how can I make it look like this thing is magnetically affected? So she just stuck these little magnets underneath the slide, and you can see that it shaped itself to the magnetic fields. So she's still thinking visually. She's thinking, oh, this stuff is beautiful. It's a nice dark green. How can I set it off in yellow? So she just slipped a yellow Post-it note up underneath the slide. So this didn't cost her anything. It just meant thinking visually. So now I'm going to give you some tools that let you do your own visuals. And to find them, you go to Explaining Research, and then to References and Resources for Chapter 4, Developing Informative Visuals. And there'll be links to all the tools that I'm going to be talking about, along with many other tools that you can use to create your own visuals. For example, National Geographic has a great tutorial on photography, so you can take nature and landscape photography more effectively. More specifically, they have a really nice tutorial on how you take macro pictures. You may be working with crystals or small objects that are not microscopic but not large, and they can show you how to take macro pictures that are just quite compelling you can use in your presentations. Also, there's a company called Macroscopic Solutions. They sell equipment for taking macroscopic images, but if you don't find it useful, if you don't take many of those images, if you just want to have a nice shot of something that's macroscopic, you can send them a sample, and they will create a macroscopic image for you, and it can be quite an engaging and compelling image to use in your presentations and even in your scientific publications. Now, my favorite tool for capturing stuff on the screen is Snagit by TechSmith. And there's a link to Snagit in the links that in the list that I gave you. You can download it and get a free trial. Now, all the video that you've seen so far, and all the manipulation that I've done of a web page, were captured using Snagit. It's an incredible tool. I'll show you some of the uses for Snagit. I took this random web page, just one that I found online. I just chose it because it looked pretty handsome. So this is what you can do with Snagit. You can highlight and magnify a particular part of an image or a web page that you've captured. So if you, for example, got a chart that you just have to show, but you want to highlight one particular part of the chart or graph, you can import it into Snagit, and you can magnify the part you want to magnify. You can throw the background out of focus and darken it so that you highlight what you want to highlight. You can also circle it if you want to. You can label different parts of the image. Here I apologize for not wearing a tie. You can add this torn page effect and other effects that sort of give a sense that there's more material below and to the right of the page or the image that you've captured. So that's Snagit. I highly recommend it. There's another technique you can use to make your images more interesting. If you're going to show a series of images, you can use Windows Movie Maker to make a moving gallery of your images. And what you do is just grab them and drag them into this timeline you see on the right, and you add a transition, usually a crossfade, and then you can go to a long list menu of choreographed movements and choreograph each movement in each slide. And this gives an example of what happens as a result. You see, I chose to pan in and upper left here, to the right and in here to get this beautiful lemur's image, down and to the left to make it look like this lemur was jumping. These are all lemurs at the Duke Lemur Center, by the way. I decided to zoom in on this guy's face because it was so compelling. This was kind of a natural for a pan, left to right pan. And this, you want to zoom in on one of these little guys' faces. Now, I'm sure you can do this with almost all video editing software, but Windows Moving Gallery is most widely used, and it's most available. Here's a good source for science slides. There's a place called Visi Science that has hundreds and hundreds of prepared science slides already online. Unfortunately for the physical scientists, they're all life science images, but here's an example. And the important thing about these slides is that you can customize them. You can take any of these graphical elements, they're all separate on the page, and you can move them around. You can change the labels, so you can customize, and you can actually move components from one slide to the other as well. So you can customize these slides to portray your research specifically. And you can also have a version for technical presentations and a version for lay-level presentations. Now, there's another piece of software that I find quite fascinating called VisiPaths, and it enables you to actually animate pathways like metabolic pathways or processes, anything that has to do with a flow chart. And you can see how you do it here. You have this workspace on the right, and you can take these shapes and I'm sure other shapes and rearrange them and add moving arrows and label them and make a really nice animated depiction of your process. A general rule is if you can make something move on your slide, do so, because you are both a predator and prey. Remember, you're a primate. Your visual cortex is activated by movement, so you'll grab your audience's attentions more if you make something move. So however, I advise that before you go and invest in other software, you take a look at the animation capabilities of PowerPoint. And here's an example. This scientist did a really nice job of animating a series of processes in the explaining the nature of apoptosis. So you can do these kinds of animated things. You can have them run on their own. You can have them run with a click. You can add labels and so forth. So explore the potential animation possibilities of PowerPoint before you invest in a lot of other software. Now we're going to talk about GIFs. They're fascinating and useful because they're so simple. They're just simple graphical files that cycle through a series of frames to give the effect of animation. And this is, of course, DNA. There's a site called Polyview 3D. It's free. You can actually upload a structure of molecule you're working on, and you can program Polyview 3D to show an animated GIF of the structure rotating, or zooming in, zooming out, or changing conformation. So it's a really nice way to very easily animate the molecule that you're working on. If you want to go find some GIFs, there's a site called jiffy.com, and they have hundreds of animated GIFs, and you can go search them to see if there's some that that you might be able to use. You can also get a sense of what people do with animated GIFs to get information across. Here's a good example of why you use an animated GIF. This is a shafak. It's a lemur. It's an arboreal lemur, but it has this really interesting hopping motion when it's on the ground. So let's say this happens. You only get a second or two of this locomotion, but you want to talk about it at length. You just create an animated GIF that cycles through this animation, so you can talk about it as long as you want and not have to worry about a lot of video. Here's another animated GIF that shows how you can animate a process, a diagrammatic process. This is actually the scariest image that I'm going to show you today. This is an animation of how a bump key works. A bump key is a key that will open any lock. A burglar can easily make one, file down these the points in a certain way so that this burglar can walk up to your door and stick the key in and walk right into your house. But now you know how a bump key works, and I hope you look at bump keys on Wikipedia to see how you can possibly protect yourself from them. This is another example. This is an interesting structure that it would be hard to understand this thing without having an animation. You can make your own GIFs, and there are about 4 or 5 sites on that list that I gave you for creating your own animated GIFs. The most popular is Make a GIF, and to use it, you just upload the images that you want to be on your animated GIF, and it will automatically make a GIF for you. Also, if you have video, you can actually upload the video or link to the video if it's on YouTube, and make a GIF, and these other animated GIF makers will pick frames out of the video and create your GIF for you. And these are all free. They don't cost anything. They take literally 10-15 minutes to learn how to use. This is a fascinating piece of software. This is not a crab claw. This is a 3D model of a crab claw, and it was made with nothing more complicated than your smartphone, the camera on your smartphone. What you do using this software called 123D Catch, you walk all the way around your subject, whether it's a fossil or a human or a building or a molecule, and you upload it to 123D Catch, and it produces this 3D model that you can manipulate in real time. 123D Catch is free, by the way. And this is a good example of how you can use 123D Catch. This is a simple, molecular model, but this is video that I captured with Snagit of me manipulating the model to show more detail in 3D. So you can see how you can make people understand more of whatever it is you're talking about if you can manipulate it as you're talking. Now, this is a video of me manipulating a model, but you can also embed these models in your PowerPoint presentation. And this is an example of a model embedded in a slide. And you can go to mulsoft.com/support. You have to log in, get an account. It's free, but you can download this plugin to PowerPoint so that you can actually embed a lot of these kinds of models right into your PowerPoint presentation, so you don't have to leave the presentation in order to show the model. Now, one of the major points I'd like to make in this presentation is that although I've talked about using visuals in presentations, visuals will also be very important in your scientific publications. And this is a good example. This is Cell's article of the future. You see that it lets authors embed graphical abstracts that explain their work. It lets them embed videos. And so more and more scientific articles are becoming multimedia encounters, experiences that are much richer and much more engaging and much more informative than the common scientific article, the one on paper, or even the static one on the web. So as you're learning these visual tools, think about how you can use them to make your scientific articles more effective and more informative. So I'm going to give you a little look at the future of visual presentations. This is a software called, this is a thing called Oculus Rift, and these goggles and the software represent the first high-resolution, real-time virtual reality system. This will be out as a product later this year, and as you can see, this guy is literally embedded in this virtual reality. It's 3 dimensions, so he feels like he's right there in it. And Oculus Rift is going to be a very powerful thing, means of visual presentations. 10 years in the future, you may be giving a talk and you may say, okay, you can either look at the slides or slip on your goggles and I can walk you into the molecule that I'm talking about or through the environment that I'm talking about. Here's another product that's just been introduced, the Microsoft HoloLens, and this is called Augmented Reality. The person wearing these goggles actually sees these virtual objects in space in front of them. They manipulate the objects with gestures and with their voice, so she's assembling something from this toolbox. So in the future, maybe you go into a presentation and your presenter says, well, put on your goggles and watch me manipulate this virtual object in space in this virtual augmented reality. You can also use these for collaboration. This guy has his HoloLens on. The ghostly-like creature, the ghostly figure there is a collaborator at a distance, 1,000 miles away, and they're collaborating on examining this Martian surface as in 3 dimensions, as rendered as the data from this Mars rover. Now, here's another fascinating look at the future. Magic Leap. They say they're going to produce equipment and software that enables you to embed very realistic objects in augmented reality. They have not got a piece of hardware or software yet, but they've had a $500 million invested by Google and other investors. So that's another possibility that you may have a very sophisticated augmented reality system in the future. So that's my presentation, and I guess, Heather, we can take some questions now.
Great, thank you. So the first question we have is from... Oh, did you want to say something?
Am I on now? I stopped my... Okay.
Yep, we're back to you. So everybody, if you didn't hear at the beginning, we're taking questions. You can type them in on the right side of your screen, and I'll read them to Dennis. The first question comes from Kevin. It says, do you find that a scientific audience reacts better to images taken directly from research or from abstract images? Does it matter when is it better to use one over the other?
I guess what you're talking about is images that reflect actual data or the research that's being done, as opposed to images that are more generic.
More generic, but an abstract idea of what you're saying.
I would say try if an abstract image seems to work, then try it. But try it on a bunch of your friends and your colleagues, and say, does this convey what I want it to convey? And if they say, well, it's too abstruse, it's not clear, then don't use it. But generally, pictures that are actual pictures of your research are better. So you saw my cows. Those are abstract images, but they were engaging, and I knew that they would grab people. So I think that's the key thing. If it grabs somebody, and if it conveys the abstract idea effectively, then those are two good criteria. If they don't use them. The best thing to do is to have a really compelling image of the actual object. You remember the image that I showed you of the ferrofluid? I mean, that was a beautiful abstract image, but it was also an image of the actual ferrofluid. So try to combine the two if possible, but if your concept is too abstract, by all means go look for some image that conveys that abstraction effectively.
Is there a way to know when you have the best image possible, the most attention-grabbing image is the only way to go and ask your friends?
That's really the best way, because I'm going to say something a little odd. Don't ask your friends. Ask people who don't like you. Ask people if you're a senior faculty member, don't ask anybody whose checks you sign. Don't ask spouses. Ask somebody who has a really good sense of what a good presentation is, but doesn't have any personal investment in you. One place to go actually is the communications department in your institution. If they're a faculty who teach how to give a talk, go see if you can buy them a cup of coffee and show them the images and see what they think. They won't have any investment in you personally, so they'll be perfectly willing to be objective. So I said don't ask your friends. Don't ask your friends. Ask your enemies.
Okay. Janice is saying, this is great information. Did you say you're providing a list of the resources you mentioned? Where will that list be posted?
In the presentation, I said go to explainingresearch.com. Under references and research, you click on explainingresearch.com on the left side, the menu item that says Explaining Research. Then you click on References and Resources, and then you click on Chapter 3 for Sources of Images, and Chapter 4 for tools that you can use to create images.
Great. And Janice, just so you know, we're going to have the link to Dennis's website, explainingresearch.com, on the description of the YouTube video. When this is finished, this will be recorded and posted to the YouTube channel. So look in that description if you can't find it.
Oh, and as I said before, email me at dennis@glyphis.com if you have any questions or if I can offer any further resources.
Great. We'll put your email in the description too.
Good.
And then Katie is asking, where do you see the art of science communication going in the future? How vital will it be to learn evolving technologies and communication skills in order to get your point across?
Well, as I said in the end, more and more scientific publications are becoming multimedia. They're becoming visual. The visual tools at your disposal are getting to be more. There's more and more visual tools at your disposal. That Chapter 4 has that lists of all those websites and tools where you can go to make your visuals. So I think it's going more and more visual because the tools are there, and people are realizing, scientists in particular, are realizing that visualization is really critical, not just to communicating their work, but understanding their work themselves. I have a slide that I didn't have time to show, but it shows prize-winning simulations that scientists did, visual simulations of their research, to help them understand the concepts and help their colleagues understand the concepts. So the tools are there, they're cheaper than ever, they're easier to use than ever, so I think more and more visualization will come along. It used to be that, for example, to do a visualization, you literally had to go talk to somebody at a supercomputer center. But now you have so many tools and so much power in these desktop computers, you can do them yourselves.
Great. And so everybody, we've gotten through all the questions that the audience has asked. So if you have any questions, just submit them to the right side, and I'll keep asking some of my questions for Dennis. You talked a lot about information that I think would pertain to PowerPoint presentations and in-person talks. What kind of advice do you have for somebody who's going to be making a poster presentation? Oh,
poster presentations are another thing entirely. You want to be as concise as you possibly can be. That is, each section should only be about 50 words. There are the usual labels that you see, abstract, abstract, introduction, and all that. I don't advise using those. Those are labels. So instead of introduction, you use a headline that gives the point of the introduction. Instead of abstract, use a headline that tells the point of the abstract. So there's that piece of advice. Then in terms of visuals, keep your visuals very simple. Don't use equations if you can possibly avoid them, because people have a lot of trouble digesting an equation just from a poster. Also, think about the fact that your poster will be seen in a crowd. People don't think about this very often, but if there's a crowd, they can't see the main part of your poster, so put your headline at the top and put the most important conclusion at the top. People are not as interested, to be honest, about who did the work and where they're from. That's what most people put at the top of their posters, but those can go at the bottom so that people read from the top down. So put the most important information at the top of your poster, and the least important, at least to your audience, the names and the affiliations and so forth at the bottom. Also, get a URL where people can go to find your data. And you don't want to give them a very complicated URL that says, you know, www.institution.laboratory.person.lab. You can actually get a simple URL and redirect it to the more complicated URL. I gave a talk, for example, at the American Association for the Advancement of Science about visualization. So I got the URL AAASvisual.com, and that's the one I gave them, and it redirected to all the information to the slideshow that I wanted to give. So you can get it. You can actually buy for $11 a year a simple URL and have it direct to wherever you want it to go. So I think I hope that helps.
Yeah, thank you. Christina is asking, for people starting their careers in science communication, do you know of any great resources, such as societies or groups, available or to become involved with and build their network?
The National Association of Science Writers is the best. That's nasw.org. You can join as a student member. Science writers are very friendly people. You can find a lot of mentors there. There are a lot of opportunities for being mentored. There are a lot of resources on the site. It's a good way to get yourself engaged with the science writing community. And by science writing, I really mean science communication. It includes reporters at publications, but it also includes public information officers and publishers and folks like that. So NASW is a terrific organization to get into.
Great. And I'm wondering, Dennis, is there ever a line or a balance that you need to think about when you think about the lightheartedness of your presentation? It seems like sometimes funny visuals and funny stories will get people engaged, but that might not always be appropriate for a scientific audience.
I do advocate using humor, because humor grabs your audience, it engages them, it connects them with you. But clearly, if you're giving a scientific presentation, you use it judiciously. But don't be afraid to make a little joke or have a funny picture in a scientific presentation if it really makes your point. And you remember the ape Einstein? That really engaged people, and it's a funny picture. But it made the point that I wanted to make, that we are primates. We are very intelligent primates, but we're still primates. So think about, in using your humor, make sure that it makes a point. And in the list of tools that I gave you, the Chapter 4 listing, there are a lot of tools there for making amusing images and finding compelling and engaging and funny images that can make your point. So as long as it's on point and as long as it's used judiciously, it can serve to connect you with your audience.
Okay, thank you. Janice is asking, how long did it take you to prepare today's presentation? What is the time commitment for adding visuals?
Some of the things that I did took very little time. For example, the Windows gallery, the particular one I showed you, it took me literally 15 or 20 minutes to learn to use the Windows editor, and another 30 minutes to put together that gallery. It's all of the tools that I gave you are ones that are pretty self-evident how to use. Now, when I'm preparing a talk, I will put the slides together, and a lot of these slides were used in previous talks that I gave. But I rehearse like crazy. When I'm giving a talk, I will get up in front of a mirror and I will go over the talk over and over and over until I know what gestures I'm going to use. I know what I'm going to say. I know even how I'm going to move on the stage. I know a lot of, I've rehearsed a lot of stuff so that there's a lot of muscle memory there. And I took this advice from watching Steve Jobs, who was, everybody knows, he was the master of presenting Apple products. And he looks, he's very energetic. He used gestures. He used movement on the stage. He never had to refer to notes because he practiced for hours on a presentation. So don't think you can just put your slides together and then put them up on the screen and walk out and talk about them. Make yourself practice so many times that it's just automatic.
Okay. Our next question comes from Kat. She says, what are some common mistakes that people make during presentations related to visuals?
First of all, they put too much data on the screen, as I showed you. Remember that your slide will only be on the screen up to 25 or 30 seconds. So if your audience is overwhelmed by that slide and they can't grasp the point you're trying to make in 20 or 30 seconds, then it's too overstuffed with data. So putting too much data on the slide. A major problem is when people slap the graph or the chart directly out of their publication up on the screen. Many times I've seen the text is too small to read. The graphs and charts are meant for print. They're not meant for slides. So you should always redo your graphs and charts to be presented to make that text 24 points or larger, make all the graphic elements of it very clear. Another big mistake people make is to forget that they are an important visual in their presentation. They will stand behind the podium, they will grab the side of the podium with their hands, they will have their head down, they will be reading their presentation or reading their notes. Get out from behind that podium. Get yourself a wireless mic so that you can walk over to your slide and make your point on the screen. So you are an important visual. Use your energy, use gestures. That's a major mistake that scientists make when they're presenting. They forget that they are an important visual.
I'm wondering what your advice is, Dennis, for scientists who work in a field that they don't see as naturally visual.
That is difficult. You saw, for example, the example of the Q surface, the mathematical surface. I would say you go find visuals that sort of represent your work, either directly or in terms of abstraction. And you can make your research visual. Now, for mathematicians, it's really a tough thing to do because, by definition, you're talking about equations. There are, however, pieces of software that let you literally animate an equation so that you can see things move around. You can see things cancel out. So the piece of advice I would give you is the one I gave you at the beginning. Use a visual vernacular. Try to make your presentations visual, whether it's using images that directly convey data or using this eye candy that I talked about.
And is there a certain ratio that you think presentation should have for visuals versus non-visuals?
I think it'll sort of fall out organically. In other words, when you're giving a presentation, a technical presentation, you know that you have to present data. But what you want to do is make those data slides as visually clear as you possibly can be. They possibly can be using the right size text and the right size figures and so forth. But you can sort of let that flow. In other words, you're going to show some data, but maybe you're going to have a conclusion from that data. Well, you show a pretty picture with the headline with that conclusion as you're talking about it. So just keep in mind how you can keep your audience engaged visually and how you have to present data at the same time and just sort of let it happen. Now, another key point is, as I've said, you go and practice a lot, but you also show your presentation to your colleagues and show it to the audience you're going to be talking to. That means, for example, if your presentation is a seminar, but you know that there will be senior faculty as well as undergraduates, you go to both types of folks and you show it to an undergraduate and you say, do you get what I'm talking about? And if the undergraduate says, no, you need more introduction, then you do that, and you can use visuals to grab the attention of that undergraduate. So you also go to the professor and you say, look, I have to talk to undergraduates as well, but does this have enough meat to it to get across the point I want to get in the most engaging and professional manner?
Great. Well, we're wrapping up. We're almost out of time. Do you have anything that you want to say as closing remarks?
Well, I hope this has helped everybody, and that you'll email me at dennis@glyphis.com. And just remember that when you're giving a presentation, your visuals are going to be very important, because your cerebral cortex, 40% of it is devoted to processing images. So use that visual vernacular and just think about what visuals you can get. Use those links that list of links that I gave you to search for good visuals, and try them out on your friends, and more importantly, try them out on your enemies.
Great, thank you. And we're going to have a recording of this Google Hangout posted to SigmaZai's website, and the place to go to find that will be on our Student Research Showcase page. It's sigmazai.org/student-research-showcase. Thank you very much for the time today.
You're very welcome.
Bye.
Bye.